Hello and welcome to another video. In this one, this is going to be a bit of an advanced video. We are going to write a Python extension. Normally you would write those in C. I did a video on C extensions. I'll link that in the description, but today we're going to be writing one in Go. So let's jump into it. Okay, so the way we're going to be doing this today, and this actually has been possible all the way back since Go 1.5, which introduced a new shared object output for Go executables. And then, the way Python loads modules is through shared objects. And so you connect the two dots, you can output a shared module from Go and then import it from Python. And so that allows Python to call into Go code. And I found this was pretty tricky to get set up, so I made a little helper setup tools extension that kind of streamlines how you would set this up. And that setup tools extension is called Setup Tools Golang, and I'm going to walk you through a few examples of writing our own C extensions, but in Go. And yeah, so if you want to learn more about this, it's on GitHub. I will try and remember to link this in the description as well. But it supports anything newer than Golang 1.5, and Go only supports the latest 2 versions, so those are the only versions that it is currently tested against. And it also works for PyPy, so you need to distribute modules for PyPy. That also works. It also works on most of the supported platforms, so it works perfectly on Linux and macOS. Windows is a little bit of a different story because CPython uses a different Windows C library than Go does for 64-bit Python, but it does work for 32-bit Python if you can find a compiler. It's really hard to find a compiler that works for both 32-bit Python and 32-bit Go, but it is certainly possible. But we're going to be working entirely on Linux today, so hopefully you'll be able to see that. And the rest of the README kind of goes through the instructions, and we're going to follow them pretty closely. And I'm going to show you a few other tricks to make this work better if you want to distribute ABI 3 wheels, for instance. But anyway, let's get started. So this is a Python project, so we're going to start with setup.py. It's kind of the easiest bit to do here. We're going to do from setup tools import setup, and we are going to name our package. Setup name equals, we're just going to call it hello world go. And the trick to make setup tools Golang work is you need to have it available at setup time. There are 2 ways to do that. The old way is to do install requires equals setup tools Golang, and the setup tools machinery will download this and make it available at setup time. The newer way is to suggest this through pyproject.toml. I don't know the syntax for that. I do know the syntax for install requires, so I'm going to show you this here. And you can look up the, setup requires stuff. Oh, actually, we want setup requires, right? Not install requires, because we want it at setup time. Install requires is at runtime. And yeah, you can look up the pyproject.toml syntax if you want to do it that way. Cool. The other thing we're going to need is ext modules. This is very close to how the C stuff works. From setup tools import extension, and inside ext modules we're going to make an extension that is whatever our module name is going to be called. So we're going to do hello world go, and we are going to list the files that go into this. Now normally, oops, I got a typo here. And normally you would list some C files here, but we're going to actually list a Go file here. Hello world go.go. And we need one last thing into this to tell setup tools Golang to do its stuff. And that is we need this special build Golang keyword argument. And we're going to tell it the module root. Now this seems a little bit weird if you've worked with Go. Like usually you just check it out into conventional space and install it there inside of your Go path, or you have a Go mod. We're actually going to set up a Go mod because you need one in Go 1.16 and above. But usually you don't need to duplicate what your module name is in a bunch of places. So this is just a bit of unfortunate history here. I think I can actually remove this now that Go 1.16 kind of requires a Go mod file, and I could probably get it from there. But for now, this is still necessary. And for our root, we're going to do our root import namespace. So let's say github.com/acetili/hello world go. And you would name it to whatever whatever your module is in whatever place. I'm actually probably not going to put this directly on GitHub. It will appear eventually in the explains repository where code samples are updated, but I'm not going to be uploading it to this particular location. So, and it doesn't really matter what this root is. You can actually give it any sort of value that you want, unless you're importing internally within your code, and then it needs to be the same import path that you would import from. But this is our basic setup.py. We're also going to add a go mod file, and you can do that by doing go mod init. And cannot determine. Oh, right. You have to tell it the go path since I'm not in it. I'm not inside of my go path, and we're just going to take this same thing here, and that'll make our go.mod file. It should look something like this. It will have whatever Go version you're using here. Next, we need to set up the actual module structure. Now, unfortunately, we can't write all of the code directly in Go because Go is missing some, kind of basic C functionality. In particular, it's missing macro resolution. So if you have like a C macro that's defining something, that's not going to be expanded in Go, so it doesn't know about macros, and it doesn't know about variadic functions. It doesn't have a good way to represent functions that take arbitrary numbers of arguments. One example of a variadic function that you might be familiar with in C is printf, which can take any number of arguments. For us, this mostly affects our pyarg parse tuple function, which is how we parse arguments out of Python C argument passing stuff. So unfortunately, we need to make a little C file here, and we're going to start by doing that first. Hello world C dot, or hello world go.c, right? And this is going to look a lot like a normal C extension. You're going to have your pound include Python. We will be grabbing some functions eventually from Go, so we're going to declare those here. I'm going to be writing two functions today. One of them is going to be a sum function, which is going to take two numbers and add them together, just kind of a silly example. And we're also going to add a hello function, which will just take, I don't know, one string and concatenate it and Go and spit out a new thing. So we're going to define these here, or we're going to declare these here, and we will define them in Go later. Now, as I said before, there's a few things that we're not going to be able to do directly in Go, and the first of those is parsing arguments, because pyarg's parse tuple is a variadic function. So we're going to define a specialized version of that in the C helper code that we can call from Go. And pyarg parse tuple. So if we're doing our sum function, this is taking two longs, and this is going to take one Unicode variable. So we're going to define, both of those to work better that way. So we're going to do pyarg parse tuple ll. I think that's the right one. Let's double check that. Python C API pyarg parse tuple. We want to look at the right formatting arguments here. S is going to, well, we need S for later. Unicode objects are converted to strings using UTF-8. Okay, so we're going to need this. So we're going to do int pyarg parse tuple S, and that's going to take in our PyObject star args, and we're going to have a char star or star. I think yeah, I think that's what we want. So this will assign a char star pointer for us. And actually, do we have to free this? What does it say here? It doesn't tell us whether we have to free it, so oh wait, it fills a py buffer structure provided by the caller. What is a py buffer? How does this work? 2 C variables. Okay, I think this is probably what we want instead. We want S. S octothorpe. So it's going to fill in a const char star pointer and a size t. I s size t star size. And we're going to basically do return I arg parse tuple. And we're going to call that with args and s and ptr and size. So normally we would be able to just call this directly in Go, but Go, again, doesn't understand that this function is variadic, so we can't do that. We're going to do a similar thing for, I think it's LL. Let me double check here. L, I think is long, right? Right. Numerics. L, long int. Convert C to a long int. Okay, cool. So we're going to take pi object star and long star A, long star B. Return pi arg. So if you haven't noticed so far, there's kind of a lot of work to getting these set up. Mostly you have to do all of these C functions just to make it so it's easy to work in Go. And you'll also set up your module def. I'm actually just going to copy and paste one that I have over here. And we are going to add our 2 functions here. Should actually order these properly up here. But this is basically the standard module setup that you would use for a C extension. And again, these aren't available in Go either because this structure is, well, this structure is available. This is available through a type def, but this is a macro and this is a macro. So we're kind of missing a lot of important parts there. And we're going to rename this to Hello World Go. And hello world go. World go. Okay, and this should be all that we need from our little helper here. I have found that sometimes you need to mark these as extern. Maybe not here. Somewhere you have to mark them as extern. I don't think it's here. Because, I don't know, some compilers are a little bit fiddly, especially on macOS, so fiddle around with marking your prototypes as extern because they do get linked together eventually. But anyway, I think this is all we need for this part here. And now we're ready to start writing our Go code. I'm actually going to put this over on the other screen because we might need it in a second. But we're going to write hello world Go. Oh my goodness, why can I not spell world today? All right, and so when you're defining your Go module here, you're going to be doing it in the package main. And you're going to have an initialization function for main that's just going to do nothing. This is what happens when the shared object is initialized, and usually you don't need to do anything for that. But the Go compiler requires that we do that here. All right, so now we're going to define our 2 functions that we mentioned earlier before. But first we need to import a special thing called C. And this triggers Go's special C Go behavior, which allows you to call C functions and interface with Go. And the way C Go works is kind of gross. You write comments that are C code directly above it, and the Go compiler machinery will read those and make those symbols available. So we are just going to do include python.h here. And we're also going to define these 2 prototypes so that we can call them in Go as well. So we're going to define both of these here. And this pi s size t is a type def, not a macro, so it should be fine to work here. If it doesn't work, we'll change it to int. And actually, I made a contribution to Go which made type defs equivalent variables, which had some unintended side effects of making different types aliases of each other as long as they're the same size and numericness. So I actually changed how Go works, which is kind of cool. All right, and so once we have all of this set up, now we should be able to write our sum function and our hello function. Well, I guess we can start with our hello first. And so remember my Go syntax, func hello. We are going to reference our self, this is kind of the special self object of modules in Python. It doesn't really do much for us. We're not actually going to use this directly, but we are going to use the args PyObject here. And as with any C extension function, we're going to return PyObject, and this is how you refer to PyObject star in Go. You have a star for a pointer, and we're using this special C namespace to access PyObject. All right, so next we need to make a C pointer, and I don't exactly remember how to do this. I think we do var s c dot care star c dot care. I think this will make a variable that's a C string. I'm not entirely sure, but we'll try that and see what happens. And we also need a variable for our s size. Size c.py s size t, and then we're going to call our function if c.py arg parse tuple s with args and reference to s and reference to size. And in Go, if this returns non-zero, that means we need to raise that means it has raised an error. And in our case, we can just return null. And this is the same as raising an exception in CPython. So this is kind of how we're going to do our argument parsing. And then we're going to do our return value. We're going to compute that in Go. So we are doing some computation in Go here. We're going to do the hello plus. And in order to convert from our C variables to Go variables, we're going to do c.goString. That is going to convert across the C and Go calling boundary here. S, and then we're going to return. So now we have a Go string, so we need to convert that back to a C string. And we can do that by doing return. I have a little bit of helper code here. Yes, we need to make a C string first. C.C string. So this is going to copy the Go string into a C string. We will need to free this variable. But first we need to convert this C string back into a Unicode object. Do that with from. All right, I'm just trying to show you searching the docs. From UTF-8, I think there is. From string and size, create a Unicode object from buffer U. The bytes will be interpreted as UTF-8 encoded. Oh, we can just use from string. Perfect. We're going to use this, and then we're going to do ret is c.py Unicode from string cstr. Then we're going to free that C string because this actually called malloc for us, so we have to do c.free cstr, and then we can return our returned Unicode object. So this should allow us to take in a string, do some concatenation in Go, and then convert it to a C string. From that, convert it into a Python Unicode, then free the C string that we created and return back eventually our return value. That should hopefully implement our hello function. Let's do our sum function at the same time. Some of these might not be right, and we will fight the compiler until they work. PyObject, and this is c.pyObject, and similar to before. Oh boy. Similar to before, we have our longs here. Car. And we're gonna do if c.pyarg parse tuple ll args a and b nil. Wow, I'm surprised I didn't use any semicolons in here. I would have thought I would have flipped back and forth from that. Okay, and here the addition or the computation is easier than this. We don't need to do any conversion here. We can just do ret is a plus b because they're both C longs, and so it knows how to add those together. And we do want to convert it back into a Python object, so we're going to do pylong from long ret, and that should implement those two functions. And that's most of the basics. Let's actually try it out and see what it does. We have been activate. Oh, one other thing that I forgot. So the setup tools machinery doesn't know that it needs to pull these 3 files along. So I usually make a manifest.in, and this is one of the few places where I make a manifest.in. And you're gonna need this, include go.mod. That'll cause it to get grafted into the source distribution. And we'll do a global include star.c star.go. That'll cause those other files to get pulled in as well. All right, so now we should be able to do python setup.py sdist. This should... I didn't typo this here. This will make our source distribution. And we're mostly just making sure that this contains the go mod, the C file, and the go file, which it does. That's good. And then next we're going to try and install that. Pip install dist/this. And this is probably where things error because we have done something wrong. And there's a lot of red, so yes. That is safe to ignore. Hello world go, line 21. Expected declaration found, parentheses. 21. Oh, yes, indeed. There is a stray parentheses there. Oh, another thing that I've forgotten. So Go is very name convention driven, and lowercase functions are by default private, and so they aren't exported. So we have to use another magical comment here to force these functions to be available outside of this module. So that's what that is. Let's see what the next set of errors is. Line 21. Did I make the same mistake twice? Line 21. What about line 24? Expected declaration found if. Oh, right, we're compiling the old code. Let's just do pip install dot. That way it's referencing our up-to-date code. Now that we know things work. PyObject star. Parameter name omitted. Oh. I screwed up the C code. Of course. Yep. Sure enough. Need that. Let's try it again. Might work this time? Nope. Still not working. No new variables on the left-hand side of colon equals. Line 17. Oh. I redeclared a variable with that, so we need to make sure it's the same type. And a little bit of guess and check here. But you get to see the very real the very real iteration process here. Non-bool function literal type cint used as an if condition. Non-boolean. Oh, I see. Go has strict strict boolean checks here, so we need to actually check if it's null. That should fix that one. Cannot use cgo as type unsafe.pointer and argument to free. Type care. Well, we can just remove the free then. I was pretty sure I need the free here. Wait, let me check my code. Yeah. Oh, right. You have to cast it to unsafe pointer because this is char star and free takes void star, and Go gets real grumpy about conversion to void star, so you have to explicitly convert it to do that. Oh, and I probably have to import unsafe too. True, yeah. Yep, unsafe. Please work this time. Oh, thank goodness. Okay, so now it is built and installed. Usually that means it works, but let's actually import it and try. Hello world go. Hello world go.sum 100337. Oh, that worked. Let's try our hello function. Hello, thanks Tilly. Hey, look at that. So we were able to write some code in Go and call it directly from C. Now you can see this is pretty annoying to debug. I went through quite a few rounds to get this working, but it mostly works. A few things that were fiddly. We mentioned the exports, we mentioned the variadic stuff. We didn't actually have to do any macro patching here, but one example of a macro that you probably will need to do in your code is the decref macro, which is probably the most common thing you use for, or incref and decref, if you're doing reference counting in Python. So you might have to do something like void mymod decref and pyObject star obj. You might have to make functions that look like this because decref is a macro, so it won't necessarily be available in there. Cool. So now that that's done, I did want to show you one other thing with this, which is enabling ABI3 with this. And the way you enable ABI3 is very similar to how we did it for C modules. So if I actually we show the ABI3 from a C module. Let's see, all repos, and there it's code. 135. Again, this is some annoying copy paste code, so Rev6 hopefully has this. Yeah, so and don't worry about not being able to see it because we're going to copy it over to this side. So we're going to add a special beatist wheel command class, which is going to override our PyLimited API. This will cause our built extension to be ABI3 compatible. And we also need to add these two parameters into our extension. And setup-tools Golang knows about those, so it'll forward them along and make sure that things are named properly. Do this here. And this should define the PyLimited API. And if we rebuild this, it's going to go. Let's delete the build directory. Oh, we don't have a build directory. We're just going to make a wheel here. Cool. We need to import system platform, I guess. Import platform, import sys. So this should build our wheel. And if we look at this, you can see, oh, why did we not get the ABI3 here? Oh, right, because we need to actually command class equals command class, because we don't have our behavior. Okay, so this should make our ABI3 wheel. And it does. And if we do unzip-l, which will list the files in it, we should see, yep, we see an ABI3.so file. This is our built many Linux, or sorry, not many Linux, our built ABI3 extension. And I did a video on ABI3, so I will link that in the description below. And yeah, hopefully, man, this was a lot. Hopefully this was helpful. There are a lot of stumbling points, and I've tried to go over most of them inside the README. And there's also links to a bunch of examples here as well. So if you want to check out some of those examples here, as well as the original reason that I wrote this whole module in the first place. I wanted access to the official Dockerfile parser in Python because I was going to write a Dockerfile linter. I never ended up writing the Dockerfile linter because I went down this crazy rabbit hole to build setup-tools Golang, and I spent like a couple months on, or a couple weeks on that, and then gave up on the original idea. But this is, a living example of a C extension that was written in Go. So here's how that works. And I actually had to export a bunch of other stuff because I raise exceptions. I had to construct a class. Here's that macro that I was talking about. There's a whole bunch of stuff in here that I had to shim over, but Anyway, there's a bunch of examples that you can check out. So hopefully, even if this video doesn't help you get to a solution, you can try those out as well. And there's also a bunch of common errors that I've collected down here. And there's a special tool that helps you build many Linux wheels if you want to. Anyway, hopefully this was useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.